Hi everyone, my name is Abdulwali and welcome to my video. This video is going to be about physics chapter 16, concept phase and initial phase. So if you're given the argument, the position argument or position function, a cosine wt, the x of t is our position, a is our amplitude, and w is our angular frequency, and t is a time variable. So in this scenario, if you draw this graph out, you'll get this graph. And let me walk you through what, how that's about. So you say t equals 0, you're going to say w times 0 is 0. Cosine of 0 is 1. 1 times a is a. A is our amplitude. So therefore x of t at 0 is a. So therefore our amplitude is going to start at 0. Our amplitude at point 0 is going to start at a. So if you draw this graph, if you use this graph and depicted it in a scenario like a mass and a spring constant, it's going to look like this. So at our initial data at x0, our block is stretched all the way to the left side, and it's stretched to x equals a, to the position of x equals a, and our equilibrium is past our equilibrium point. And the fact that it's all the way over there, if you look at back our graph, you see that the velocity is going to be pushing this way because it's been stretched so it's been stretched to the left so far that it's coming this way. And you can also double check if that matches our graph, because if you take if you see over here of our graph, you see the slope over here is negative. So, and you know that x of t is position, and you know that v of t is velocity. You also know that if you take the derivative of x of t, that's going to be your velocity. And another way of thinking about derivative is slope. So if you take the slope of this, if you take the slope of that point, you just know that it's going to be negative. And then after some time, it's going to t is going to equal t at some time is going to equal pi over fourth. And pi over fourth, you know that our a value is going to be 0, and that's going to make it's going to hit our equilibrium point. That's going to go back. That's going to go forward. It's going to go forward, and then that's how it works. So over here is going to be negative value. Then over here is going to go positive, and the negative is going to be a negative slope, and positive slope, negative slope, positive slope. And our negative positive slope is going to determine which direction is our velocity, which way our block is going. And then when the slope over here and over here is 0, that's when you know it has basically it's switching sides. So if it was going to the left, now it's going to the right. It's going to the right. It's going to the left. So that's our switching. And then at this point, when it's 0, at those critical points, that's when it reaches its equilibrium. So now that you know how that operates, I'm going to talk about this next function. So the difference between this function and the previous function was that before we didn't have an initial phase, but now we include in this initial phase negative pi over 2. So negative pi over 2, if you draw a circle and you go to negative pi over 2, you know that that point is going to be 0. That point is going to be 0 for cosine. So we say w of t when t equals 0 minus pi over 2 is going to be minus pi over 2. 0 minus pi over 2 is minus pi over 2. And we went minus pi over 2 down, then cosine of 0, cosine of negative pi over 2 equals 0. So therefore, 0 times a is going to be 0. So therefore, you're going to start at t equals t of 0 at 0. And so x of 0 is going to be 0, and then you're gonna go up, and you're gonna go down, you're gonna go up, and then you're gonna go down, and you go like that. So another way to check my knowledge, if I'm drawing it right, you could revisit what does negative pi over 2 means. So when our initial phase is negative, that means it went to the positive side, right? And if it would have been plus. So if it's negative pi over 2, that means it's shifted to the right. So if you look at a previous case, if this was shifted to the right, it would look like this. Why? This is a period. So if you look at this portion is equivalent to one another. So if you shifted this one to the right, then this would be included. So all this would have been converted to here. And then that's why, so all this would be transitioned to here, and that matches. So therefore that's right. And then if you wanted to use this graph and you wanted to depict a scenario that's like, in this case, you could say, okay, at x of 0, it equals 0, and if it's equal to 0, that means you start at an equilibrium point. So the block starts at the equilibrium point, and that's it, and right. And so then now you know that if you say what's the slope, which direction is it going? Is it going this direction? If it's going that direction, you're just going to look at the slope, and you see that at that point, the slope is positive because you take like tangent line, and you see this is positive, and you know that means it's moving to the right. Vmax at a constant at a Vmax. So Vmax at a Vmax. So now, so that's what happened there. So now if you have a cosine wt plus pi over 2, what changed from the original function was that plus pi over 2. So now if you have plus pi over 2, that's your initial phase, right? So what happens from this function to this function? So you add a pi over 2. So what changes? Does it go to the left? Does it go to the right? It's going to go to the left. Why? Because it's plus. It's going to go to the left because it's plus. So if our function was like this, let me erase that. That plus pi over 2 is making is going to make us move to the left. So now this whole thing is going to be shifted to the left. So that means it's going to look like this. Let me illustrate it. Rough sketch. So that means x of 0 is going to be shifted. It's going to be x of 0 is going to be 0. So that means our block started from the equilibrium point. And if you see it over here, if you find the slope of this, you see the slope is negative. So that means at that point the velocity is coming back this direction. It's moving the block is moving this direction. So another good thing to note from this is that this function can be rewritten differently, right? If you look at carefully of this function, of this graph, you can rewrite this function, right? So this function is equivalent to a sine of wt, right? For the sine function, it starts from here and it goes like that. So that's another way to rewrite it. And then you could also double check that that's right, because you could say, okay, at t equals 0, sine of 0 is 1. So if you do this, t of 0, actually, so if you say t of 0, sine of 0 is actually 0, and 0 times a, and it's going to make it x of t, x of 0 is going to be equal to 0, and that matches. So, yeah, and then if you said, say like x of, so you said pi over 2, so you said t equals to pi over 2, and you draw this again, go over here, it's going to equal to 1, this one's going to equal to 1, 1 times a is a, so that's going to make it a positive value. So if you go, and that's correct because you see that over here is 1. So then if you say, okay, what about pi? It's going to equal to 0, and that's pi. And then if you say, okay, what about 3 pi over 2? 3 pi over 2 is going to be negative 1, right? So negative 1, this is going to be negative 1, and negative 1 times a is going to be negative a, and we're going to be at a minimum value, a maximum value. So that's how you can double check. So, so I hope you guys gain a lot from this, and this is all. This a spring is another way of thinking about it as superharmonic motion. So a superharmonic motion goes through the sinusoidal waves. So if it matches a sinusoidal wave, there's most likely a superharmonic motion. So the phase is the argument, and the initial phase in the phase is the phi. So if they give you, if they tell you what's phi, phi is the initial phase, and they say, okay, what is the phase? If they say a generic, what is the phase? Is the argument of the cosine function. So the phase is the argument of the cosine function, and phi is the initial phase. And they ask you what's phi, they're gonna look for if there is an initial phase, and it's usually when it's added to the angular friction times time. So if they throw something at you out of homework or exam, phi is the initial phase. If they ask you what's the phase is this. And if they ask you angular frequency, it's the W, and angular frequency is related to KNM, right? So, yeah. Thank you so much for watching my video. I hope you guys learned. I hope you guys enjoyed. Thank you so much.